Good evening. Today we will discuss some questions from exercise 2A and it will be our fourth video on complex number. And here we just try to follow one kind of series, and series is based on the all question which is given in exercise 2A scheme of a book on complex number. So now today we'll continue from question number 11. It is exactly given in exercise 2A scheme of a book. What is the question that is given in example 11? So the question is, let Z be a complex number such that mod of Z minus 10 by Z, that modulus is equals to 3. Find the greatest and the least value of mod Z. Solution. Actually, this kind of question you will see in different competitive examination like KVS, PGT, TGT, NVS, Army Public School, WBSSC. The question is basically about the greatest and least value of modulus. Greatest and least value of mod Z. This is basically type of the question paper. Now when you will do that kind of problem, the greatest and least value of mod Z, you try to use this kind of trick we just consider is as a recall. The recall is mod of alpha minus beta, mod beta, that modulus always less than equals to mod alpha minus beta. For all alpha beta belongs to the complex number. So this is a very important trick, and for doing this kind of problem we need to follow or we need to apply this kind of recall that we already know. So now I always ask the question like this: what is exactly given in your question paper and what you have to do? So what is given? The given part is Z belongs to C such that complex number such that modulus of Z minus 10 by Z, that is equals to 3. What we have to prove? We have to find that the greatest value and least value of modulus Z. Now one thing is very important here. The thing is, when you will take, this is the recall 2, just to memorize this recall 1 and recall 2. Modulus of Z always greater than equals to 0 for all Z belongs to C. So we just consider here, let mod Z equals to R, and we try to use the inequality which is exactly written in recall 1. The inequality is basically then mod of Z minus mod 10 by Z, that modulus less than equals to mod of Z minus 10 by Z. Just start. So just you think by start. So now what is exactly given? Mod of Z minus 10 by Z equals to 3. We just put here. So it will be R minus 10 by R, that modulus less than equals to 3. since modulus of z equals to r and mod of z minus 10 by z, that modulus value is 3. This is exactly given. So from this inequality, we can write r square minus 3r minus 10. This is less than 0, or r square plus 3r minus 10. This is greater than equal 0. So from this two inequality, just you try to solve the inequality, you will get 2 less than equals to r less than equals to 5. Why? Just you consider the first inequality, r square minus 3r minus 10 less than equals to 0. So that you can write r minus 5 multiple r plus 2 less than equals to 0. So that means minus 2 less than equal r less than equals to 5. That means 0 less than equals to r less than equals to 5, because r is greater than equals to 0, as r equals to modulus. Again, when r square plus 3r minus 10 greater than equals to 0, in that case you will write r plus 5 r minus 10. This is greater than equals to 0. So r greater than equals to 2 or r less than equals to minus 5. Since r greater than equals to 0, so it implies that part will be right. So r greater than equals to 2. Here we see r greater than equals to 2, and here you have seen here r less than equals to 5. So the first case 0 to 5, in that interval r belongs. The second case r is greater than equals to 2. So the common position is that the r range is greater than equals to 2, less equals to 5. So hence you can see that r is always greater than equals to 5. That means the least value of r is 2, and r is less than equals to 5. That means the least value, the greatest value of r is 5. So from this we can write the least value of mod z is 2, and the greatest value of mod z is 5, since r equals to mod z. So this is proved. Now the next question, question number 12, which is exactly given in the exercise. Z is a variable complex number such that mod of z minus 1 by z, this is equals to 4. Show that, again the similar kind of question, so that the greatest and least value, of modulus of z are root 5 minus 2 plus 2. This is the greatest value, and least value is root 5 minus 2 respectively. So how we will solve? In similar way, let r equals to mod z, just like the previous question paper. Then we can use the inequality, mod of z minus 1 by z, that modulus, less than equals to mod z minus 1 by z, because since mod of alpha, mod beta, whole modulus less than equals to mod alpha minus beta, for all alpha beta belongs to complex number. So this value again is 4, it is given. So r minus 1 by mod r, 1 by r, that value modulus less than equals to 4. So that means minus 4 less than equals to r minus 1 by r less than equals to 4. And hence we can write r square minus 4r minus 1 less equals to 0. R square plus 4r minus 1 greater than equal to 0. So just you will solve the equation r square minus 4r minus 1 equals to 0. This is less equals to 0. That exactly means r minus 2 plus root 5 multiple r minus 2 plus minus 2 minus root 5. This is less than equals to 0, and from this you can write r less than equals to root 5 plus 2 and r greater than equal 2 minus root 5. So now since r greater than equals to 0, that means here 0 less than r less than equals to root 5 plus 2. That will be the region of r, the first case. In the second case, when you will take r square plus 4r minus 1 greater than equals to 0, you will see here r greater than equals to 2 plus root 5 and also r greater than equals to minus 2 plus root 5. Again, since r greater than equals to 0, so this implies r is greater than equals to root 5 minus 2. So just you combining these two, the range of r will be root 5 minus 2 less than equals to r less than equals to root 5 plus 2. So therefore the greatest value of mod z is root 5 plus 2 and the least value of mod z is root 5 minus 2. Now the question is given like this when it is given exactly different competitive examination. The question paper is in the pattern of MCQ type. So on that case, you have given the question paper, let z be a complex number such that mod of z minus 10 by z equals to 3, then the greatest value of mod z is, we have given the option A, say 2, option B 5, option C and option D 10. So we have seen the problem z minus 10 by z, that modulus is 3. On that case, the greatest value of mod z, I have already solved it. The greatest value is 5 and least value is 2. So the 5 is the correct answer. You can ask the similar kind of question in MCQ type. Let z belongs to C be such that mod of z minus 1 by z, this is equals to 4. Then the greatest value of mod z is option A, root 5 plus 2, option B, root 5 minus 2, option C, 4, and option D 5. So the greatest value is root 5 plus 2. That we have already done in the previous problem. So this kind of question has been asked in different competitive examination and obviously in mathematics subject. This problem is also important in IIT level, in TIFR. Now the next question is which is given in the exercise. Question number 13. Three complex number Z1, Z2, Z3 be such that Z1 plus Z2 plus Z3 equals to 0 and mod Z1 equals to mod Z2 equals to mod Z3, then prove that they represents the vertices of an equilateral triangle in the complex plane. This is a question. We need to solve it. So solution. So as usual, what is given here? Given Z1, Z2, Z3, all are complex number, and sum of this complex number, this is basically 0. First information. Second information, the modulus of Z1 equals to modulus of Z2 equals to modulus of Z3. What we have to prove? We have to prove that they represents the vertices of an equilateral triangle. Okay. So as per example, you just think it geometrically in the complex plane. Say you have given that kind of, say Z1 is here and Z2 is here and Z3 is here. So this is Z1, Z2, Z3 like this. So it basically represents an equilateral triangle because all angle is basically the 60 degree and the distance from origin are basically mod Z1, mod Z2 and mod Z3. They are equal in magnitude. So now how we will prove that? First, we have Z1 plus Z2 plus Z3 equals to 0. We can write it Z1 plus Z2 equals to minus Z3. And from this you can write mod Z1 plus Z2, take the modulus and you will do the whole square on both sides. So on that case it will be Z1 plus Z2, Z1 plus Z2 bar. This is equals to mod Z3 whole square. As we already know, modulus of alpha whole square equals to minus mod alpha whole square for all alpha belongs to C, and mod Z square, that will be Z bar for all Z belongs to C. So from here we can write Z1 plus Z2 multiple Z1 bar plus Z2 bar, that will be mod Z3 whole square. So that means Z1 bar plus Z1 Z2 bar plus Z2 Z1 bar plus Z2 Z2 bar. This is equals to mod Z3 whole square. From this we can write mod Z1 square plus Z1 Z2 bar, Z2 Z1 bar plus Z2 mod Z2 whole square equals to mod Z3 whole square. Now we just apply these things. Mod Z1 equals to mod Z2 equals to mod Z3, because this condition is already given. So from this we can write Z1 Z2 bar plus Z2 Z1 bar. This value will be minus mod Z1 square. Similarly, in the similar way, you can show that Z2 Z3 bar plus Z3 Z2 bar, that is also minus mod Z1 square. Just since Z1 plus Z2 plus Z3 equals to 0, you can write it Z2 plus Z3 equals to minus Z1. And similar way, in the previous case, you can show that Z2 Z3 bar plus Z3 Z2 bar equals to minus Z1 whole square. And also you again show Z1 Z3 bar plus Z3 Z1 bar, this value will be minus mod Z1 star. This will be double star, and we can use a triple star. Okay, now we just try to think about mod Z1 minus mod Z2, because we try to see the distance between Z1 Z2 and Z2 Z3 and Z3 Z1, all the vertices distance. So this is Z1, this is Z2, this is Z3. In what way they represents equilateral triangle? The condition is, if we show the Z1 Z2, that distance is basically Z1 minus Z2. Again, that distance is basically Z2 minus Z3 modulus. And Z1 Z3, that means Z1 minus Z3, that modulus. If all the distance are basically same, that means three sides of a triangle are basically equal in magnitude. They have the same length, and also and hence we can show that this triangle ABC with vertices Z1, Z2, Z3 represents an equilateral triangle. So we need to show Z1 minus Z2 whole square. So that means it will be Z1 minus Z2 multiple Z1 bar minus Z2 bar. Since we have used Z bar equals to mod Z square, and Z1 minus Z2 whole conjugate equals to Z1 conjugate minus Z2 conjugate. So just we will simplify it. We will get mod Z1 square minus Z1 Z2 bar Z1 bar Z2 plus mod Z2 whole square. Just to think, Z1 Z2 bar and Z1 bar Z2, again it is mod minus mod Z1 square. So this will be mod Z1 square minus of minus mod Z1 square. And here we can also write mod Z2 as mod Z1 square. Since mod Z1 equals to mod Z2 and by star. Here this value is given. Just we put the value, this value here. So it will be 3 mod Z1 whole square. Again, if we calculate mod of Z1 minus Z3 whole square, in similar way it will be Z1 minus Z3, Z1 conjugate minus Z3 conjugate. It's just you will calculate, this will be mod Z1 square minus Z1 Z3 bar plus Z3 Z1 bar plus mod of Z3 whole square, and this value again will be mod of Z1 square minus of minus mod of Z1 square plus mod Z1 square. And since mod of Z3, this is equals to mod Z1, and here we apply Z1 Z3 conjugate, Z3 Z1 conjugate, this value again mod minus Z1 square. So and by triple star. So again the value is mod 3 mod Z1 square. Also mod of Z2 minus Z3 whole square, that value after similar calculation you will get, this will be again mod Z1 square. So I just represent it by 1, and this is 2, and this is 3. So therefore, from 1, 2, and 3, we get mod of Z1 minus Z2, mod of Z2 minus Z3, mod of Z1 minus Z3. So that means if we think the three vertices Z1, Z2, and Z3 in the complex plane, the distance from Z1 and Z2, that means mod Z1 minus Z2, Z2 and Z3, that means mod Z2 minus Z3, and Z1, Z3, that means mod Z1 minus. So all sides are basically same, and hence it implies an equilateral triangle. So we can write the vertices Z1, Z2, Z3 represents an equilateral triangle. Equilateral triangle. See here, the question related to this concept is very, very important, and that kind of question is given in different examination. The question is basically MCQ type. Let Z1 and Z2 be two complex number such that Z1 plus Z2 this is equals to minus 1, and mod Z1 equals to mod Z2, this is equals to 1. Then the vertices Z1, Z2 and minus 1 represents and 1 represents option A an equilateral triangle, in the complex plane. Option B, an isosceles triangle in the complex plane. Option C, an scalene triangle in the complex plane. And option D, none of the above. So obviously, just take the vertices Z3 is equals to 1, and you will see, you just observe, we observe that Z1 plus Z2 plus Z3, that is 0, because Z1 plus Z2 equals to minus 1, as we considered Z3 equals to 1 here, and also mod Z1 equals to mod Z2 equals to mod 1, this is exactly 1. It is mod Z3. So just see the above two condition in the question paper, the previous question paper. Z1, Z2, Z3, we such that Z1 plus Z2 plus Z3 equals to 0, and their modulus are basically same. Then they represent the vertices of an equilateral triangle in the complex plane. So here Z1, Z2, Z3, that means 1 represents the vertices of an equilateral triangle in the complex plane. So option A is correct, all other options are false. Thank you so much.